Welcome to a proof of concept demonstration on how an ESP8266 can be brought under the control of the configuration management Saltstack. Micropython is a Python 3 implementation written for microcontrollers and includes a subset of the Python standard library. Micropython runs on several boards and since summer 2016, after a successful Kickstarter campaign, also on the ESP8266. It features an interactive prompt, access to Pins and I2C as well as SPI, does timers and analog to digital conversion. Having a script language on a microcontroller is an easy and quick way to write some code without the need to reflash. With the USB to serial access to the supported boards on the one side and Saltstack's proxyminion concept on the other, the goal is to have an ESP8266 in a docking station mode where it receives new config files. Saltstack does DevOps automation and configuration management and has at its core a remote execution queue, because it is not constrained to an agent-based setup, but also does SSH and works with the APIs of several cloud providers. The concept of a proxyminion also fits quite nicely into its capabilities. After Saltstack's master has accepted a connection, it collects an inventory of the connected minion as cranes. It handles sensitive config data in a secure manner and calculates the delta to a defined state of a minion, handling all necessary changes in a high-state run. If a device cannot run a Salt minion or has no OS but some kind of an API, then it is possible to write a module which is interfaced by a proxyminion talking to the device in its own lingo. Here I demonstrate the first proof of concept on how to use pyboard.py from Micropython and have an ESP8266 reveal its configuration and answer to a kind of a ping. This Raspberry 2 runs the Salt master as well as its old Salt minion. Additionally, it is a proxy to the MPP1 Micropython proxyminion number 1. It has a loopback cable on its hardware serial pins and the ESP8266 connected with a UART cable. Because Saltstack is written with Python 2.7, I am using the two wrapper shells available, MPy from Adafruit with quick access to the file system of the Micropython firmware or file down and upload. The MPF shell gives me a clean wrapper to pyboard.py, which is Micropython's implementation of serial access and is used in the proxyminion code. Plain Python of course also works, as with Arduino's method of toggling the DTR pin does reset the board. Very convenient if the board is out of reach. For demonstration purposes, the proxyminion is started in the foreground with debug log level. A quick test.ping shows the device answered to the connection. But more interesting is the output of some cranes, hardware and software inventory. This ESP8266 was flashed with Micropython version 1.8.2. ESP-Tool is the helper program to flash firmware to the ESP8266 and can be downloaded from GitHub. The ESP8266 is now reflashed with a new Micropython firmware. Between erasing its flash memory and firmware loading, I found 10 seconds of sleep necessary to have the device settle down. Again, if the reset button is out of reach, a remote reset is easy to do. To have the remote shell tools working, they require that the debug setting is turned off, but the newly flashed firmware has it on. Uploading the former boot.py fixes that. One could also compile one's own firmware settings and include all necessary changes before uploading. Another reset doesn't hurt, and the new cranes inventory items are pulled into Saltstack. This ends the short demonstration. My next steps are to enable file upload to the ESP8266 via this USB to serial docking station mode.